I don't really understand what we're talking about because anything like, wait, what are we even saying? Yeah, so uh join one of my live streams if you haven't already. The links are down below for my other YouTube channel and my Twitch. I live stream on both about 4 times a week. Also my Patreon that has content that you haven't seen if you haven't joined.
You need us jar opening, oil changing, spiders squishing, furniture rearranging men a lot more than we need you.
Today I'm going to be reacting to the multiverse hypothesis explained by Neil deGrasse Tyson.
I believe this is the only universe. There's not just one universe. There's a multiverse.
We think, when I say we, just the scientific community, physicists who concern themselves with the very early universe, cosmologists, that the laws of physics as we experience them are set in the very earliest stages of the universe. And quantum fluctuations in everything would be responsible for another universe having slightly different laws of physics than ours.
Gosh, how much brain rot does a person have to see the little visual representation of, I think he was talking about atoms at that point, but whatever it was. I don't think that it represented it, but it was a visual of a bunch of little orbs. I was imagining, never mind, just brain rot. It's fine.
Another universe having slightly different laws of physics than ours, because the quantum fluctuations will take it in a slightly different law of physics direction than our universe. And this would just keep going. Every universe that's born, even if it started out sort of the same in the very first instant, a later instant when other laws of physics manifest, could be slightly different.
These are the moments where it's a bit more obvious, and I'll try not to say this in every video that's about science, history, or anything educational in any aspect, that I'm dumb or something, because that's going to get really old really fast. Not everybody can know everything, and even if you are interested in something, maybe you haven't looked into it in several years. Maybe you forgot. Maybe you don't remember the terminology. So it's okay. Part of this is supposed to be a reaction because it's a learning experience. I don't look at videos like this very often, ever. Haven't in a really long time, so it's not going to be one of those things where I say, oh yeah, input scientific fact that has to do with what he's talking about. It just leaves a little bit less room to say stuff.
The concept of infinite worlds is a very old idea discussed in the philosophy of ancient Greek atomism, which states that the physical world is composed of fundamental indivisible components known as atoms. Ancient philosophers proposed that infinite parallel worlds arose from the collision of atoms. In the 3rd century BC, philosopher Chrysippus suggested that the world eternally expired and regenerated, effectively suggesting the existence of multiple universes across time.
It's almost as if they still exist somewhere else. They're not the same person because they have a completely different timeline, but if it's another timeline, they could only be different by maybe one action. I mean, maybe it could even be backwards in time, but for the most part, it almost sounds like most of it's talked about. Everything's going exactly at the same time, everything's linear. Which is weird because the butterfly effect would affect other people. Eventually, wouldn't it spread so far apart that they're not even close anymore?
However, the concept of multiple universes has reached maturity only in the time of modern physics. In Dublin in 1952, Irwin Schrodinger gave a lecture in which he warned his audience that what he was about to say might seem lunatic. He said that when his equations seemed to describe several different histories, these were not alternatives, but all really happened simultaneously.
Breathing. It is a really fascinating subject, multiverse. It's also interesting how stuff like movies and just media in general that's doing it for entertainment can make something like this sound so corny, because it's been pushed so much in movies and media that it's the most that you've heard the word probably recently, unless you're looking this stuff up, maybe has been in Disney movies. So it almost has a tie now to something that sounds very, oh, well, it's just a theory, like it's just a hypothesis. So it's almost cartoony to think about because it's so crazy to think about it.
This sort of duality is called superposition, which is a hard concept to grasp in and of itself. And understandably so, our brains are not evolutionarily equipped to intuitively understand quantum mechanics and large-scale cosmic phenomena.
Oh, really?
But we'll give it a try anyway.
With the multiverse, where there could be pockets of the universe that are expanding with no knowledge of any other pockets of the universe. These are essentially independent universes from one another, and never the twain will meet. Imagine you're a ship at sea and you look to the horizon, and that's your whole universe there to the horizon. There's another ship that has its own horizon, and these ships don't even see each other. You'll only see each other if somehow your two horizons can overlap. And we don't know how to do that in our universe because they're non-causal. You'd have to find some way to tunnel from one universe to the other in order to access that, but that could be very dangerous. Because if the laws of physics are different than the ones you evolved on, then you could just dissolve into a pile of goo because the charge on the electron is different and all of your biochemistry would change.
That part makes sense to imagine in theory. It would make sense. Also, like how he described it visually with the two ships looking at a horizon. It's easier for us to understand because we can imagine what a ship is, and we can imagine it being alone in water, and we can imagine it not knowing that there's another ship out there looking maybe in the same direction, but it's not really the same direction because they're both looking at a horizon where the sun is setting, but it's the exact same spot maybe even, but it's not in the same universe. It's not in the same existence. They both exist, maybe different people, but they don't know how to even see each other from this direction or know that they're overlapping without them existing together. But if you do try to draw this tunnel or line or door or whatever it would be to connect them, it's interesting to think about, well, if they work differently and there's anything there that functions different, which in theory, of course, some things would, then it could destroy both. It could be like a black hole. You don't fully understand it, but you understand enough to know, hey, it's probably not good to go in one. It looks like it kind of separates you and everything. Maybe you can come out on the other side. Maybe there's something that almost puts you back together again or refracts light in a certain way. I don't know. It looks like you get ripped apart. But it's interesting to imagine that if somehow you could work it out in your mind and it does exist, then you could exist on a different blank, different multiverse.
The multiverse is a hypothetical group of multiple universes. Together, these universes comprise everything that exists, the entirety of space, time, matter, energy, information, and the physical laws and constants that describe them. The different universes within the multiverse are called parallel universes, alternate universes, or many worlds. In pop culture, they are known as parallel dimensions, quantum realities, alternate realities, etc. The physics community has debated the various multiverse theories over time. Prominent physicists are divided about whether other universes exist outside of our own. Some physicists say the multiverse is not a legitimate topic of scientific inquiry. Concerns have been raised about whether attempts to exempt the multiverse from experimental verification could erode public confidence in science and ultimately damage the study of fundamental physics.
Even people who are so intelligent and smart are going to have different ideas of theories and different things that should be studied and have more funding because, oh, this one just kind of sounds ridiculous. And the more you look into it, the more you're going to realize that it's kind of just a circle, which is why we haven't discovered anything in so long. Oh, but this theory makes more sense because of this. So until something's discovered, there's a lot of different theories for whatever you're looking into. I could see how some people say, you don't think that discovering or trying to figure out multiverses is just an utter waste of time? Because even if we did, what are we going to do about it? We're going to explore it? What if this multiverse is so dangerous that they exist with something that can make them exist and themselves if something were to open up some type of tunnel? But our multiverse or our reality only exists on one plane because we don't have that extra element or we don't have that extra thing or whatever it is that exists that we don't understand. So if we do somehow overlap something, only our existence would be affected and theirs would be fine. Theirs would absorb ours or something weird like that. It just seems like something that's very almost fantasy. And I know everything at one point was kind of, that's not real, that's a fantasy. Or the world is flat, or gravity's not, whatever. But I could just see how some people would say, This is going to make people not take the entire study of things in this field seriously, because this is like the small portion of people that were kind of embarrassed about, like, oh, don't associate with those people who study multiverse.
Some have argued that the multiverse is a philosophical notion rather than a scientific hypothesis because it cannot be empirically falsified. The ability to disprove a theory by means of scientific experiment has always been part of the accepted scientific method. Nobel laureate Steve Weinberg suggested that if the multiverse existed, the hope of finding a rational explanation for the precise values of quark masses and other constants of the standard model that we observe in our Big Bang is doomed, for their values would be an accident of the particular part of the multiverse in which we live.
That part I don't fully understand, but I guess it's similar to if you do finally discover this, then it's kind of doomed in the first place, because upon discovering that would mean something has happened, because now we have access to the thing that could hurt. Now it's not only, I don't know how to reiterate it, and I'm not even sure if I understand that part. Like the idea of, well, it always should have the space to be a theory unless you can disprove it specifically. Sure, you might not be able to prove it for many, many years, but that shouldn't be the reason why we disregard it just because we're not able to prove it, because that's what a theory is. It should always be open to be out there as a theory until we can prove otherwise. It makes me think of this thing that if you're looking at it, it behaves differently, but they don't know how to explain why it behaves differently just because somebody's looking at it. Because as soon as you look away, these atoms or particles react or perform a certain way in like a certain light. They move in a certain line or in a certain way. But then as soon as you look at it with no other factors adding to the situation, just you looking at it physically with your eyes, it reacts differently.
There could be a universe where the laws of physics there will never allow matter to coalesce. You'll never get stars. That would be a lifeless universe. There could be another universe where you can make stars, but you don't make heavy elements. That would be a universe with stars, beautiful night skies as we have now, but nothing that we know and love. No planets, no life.
And a lot of what's been in the media is a multiverse that conveniently has worked out essentially the same as ours. And again, the theory is that there's trillions, there's an infinity amount of, at least that we're not putting a number on, almost an endless amount of supply of multiverses. So fine, I'm sure at some point you're going to get quite a few of them that match ours exactly because they only have tiny differences. Or maybe they were exactly the same up until recently. I mean, there's so many that some of the differences might have started so early on that, yeah, that one doesn't have stars, so there's no life. Or this one didn't have this type of gas that doesn't provide some type of development in creatures, so there's no life that way. Maybe there's another one where water doesn't exist, so only things that are somehow alive have this other element, and it's not water, but it's definitely not people because it grew in a completely different direction, so it's just something that we also, again, don't understand. But then maybe it's something else where everything worked out exactly the same up until 12 years ago. 12 years ago, there was an asteroid. And it didn't kill everybody, but it did something.
Some scientists analyzed the data from the Wilkinson Microwave Anisotropy Probe, an uncrewed spacecraft operating from 2001 to 2010 that measured temperature differences across the sky in cosmic microwave background, the radiant heat emitted from the Big Bang, and claimed they found evidence suggesting that our universe collided with other parallel universes in the distant past. However, a more thorough data analysis from the Wilkinson Microwave Anisotropy Probe and from the Planck satellite,
Such a
a
long
space
name.
observatory operated by the European Space Agency from 2009 to 2013, which mapped the anisotropies of the cosmic microwave background, did not find any statistical significant evidence of universe collisions. There was no evidence of any gravitational pull of other universes on ours either. And to add insult to injury to the proponents that the multiverse hypothesis has been backed up by statistical evidence, the Planck satellite has a resolution 3 times higher than the WMA probe.
Wilkins Microwave Anisotropy Probe. MAP. The MAP did not find significant evidence of them claiming that the Big Bang showed that this universe has collided in the past with another universe. Boom, got it, I think. Yeah. I'm sure whenever theories exist, and one of the only things that was claimed to try to support that theory with evidence was disproven, it does kind of make people question harsher that theory, because one of the only things that has come out about it is the the evidence that that thing didn't actually happen.
In the 1920s, quantum mechanics was invented, discovered, however you want to think scientific advances take place. Quantum mechanics is the study of the small, how particles behave. And we learned that if you get to a small enough scale, you lose the ability to predict with precision the behavior of the system. And you can only describe it statistically. And there are ranges of things it can do, and all you can describe is the range of properties that it may have.
That theory or hypothesis of when you are that small, we can't determine how particles operate around you. Time might even be treated differently. So if we could, in theory, make you as a person that tiny to quantum mechanics level tiny, atoms and everything around you is just unpredictable. It starts getting into a new theory where things start operating around you differently because you're so small. Maybe even time is treated differently. So how is that? How is time around you when you're that small versus everyone else not that small?
Well, here's this big grand universe we have described by Einstein's general theory of relativity.
Oh, I feel like
But at the Big Bang, the entire universe was the size of an atom. And so you have the need to have the physics of the small, quantum mechanics, marry the physics of the large, general relativity, because they're occupying the same space.
Quantum mechanics marry the physics of the large, general relativity, because they're occupying the same space or something like that. Yeah, I don't think I understand any of that, actually. Yeah, maybe if you can figure this out, quantum mechanics, it'll help you prove or disprove this hypothesis. Because we do know that things behave differently when they get to quantum size, and maybe that can explain how you would be able to reach something on a bigger scale. Because when you get really, really, really tiny and things behave a way that we can't fully explain, maybe it would work the same way if you get them really, really large. I don't know if that's what they're saying, but yeah, I think that goes into something else. I'm sure it has nothing to do in relation to Schrodinger's cat, but it also makes me think about how people will argue, oh, both of them don't exist. It does exist, it's just undiscovered. So it is only one thing. It's one thing, it's either dead or alive, and I know you don't know if it is or isn't, but it's just one thing. But then I guess the theory would argue, no, they both exist at the same time, but only one of them exists to us when we discover which one that is. It's either dead or alive, it's both. Until you open it, the cat is either alive or it's dead, but it is both dead and alive until you discover it. Schrodinger's cat. Or maybe in another universe, because it's only one or two differences, obviously an endless amount, it's not all going to be an alive cat. So both possibilities do exist. Both of them exist right now. But the discovery or seeing it, I don't think I'm even explaining that one right.
At no point were you even close to anything that could be considered a rational thought. I award you no points, and may God have mercy on your soul.
Now, when you take quantum mechanics and apply it to aspects of the fabric of space on that scale, what you have is a gurgling of the fabric of space-time. In fact, it's been called a quantum foam. And so now, when you look at the foam, applying the laws of quantum mechanics to it, you realize that this fabric is not limited to one zone or another. In fact, there's a region of the fabric that could hatch out an entire universe with the variations in the laws of physics simply because the conditions that would spawn the laws of physics had variation in them.
This is mental Olympics. Yeah. Yep. Oh my god.
Spawned the laws of physics had variation in them. And so the multiverse is not just some invention out of the ether. It flows out of an application of quantum mechanics to general relativity.
Prominent scientists such as Max Tegmark and Brian Greene have devised classification schemes for the various theoretical types of multiverses and universes that they might comprise. Max Tegmark has provided a taxonomy of 4 levels of universe beyond the familiar observable universe.
I am struggling.
Has provided a taxonomy of 4 levels of universe beyond the familiar observable universe. Level 1 is an extension of our universe. A prediction of cosmic inflation is the existence of an infinite ergodic universe, which, being infinite, must contain Hubble volumes, realizing all initial conditions.
Darn, we're not always gonna have something. And I have nothing. I apologize. Level 1, a bit hard to compute. Yeah. The observable universe, level 1, is an extension of our universe. A prediction of cosmic inflation is the existence of an ergodic universe, which, being infinite, must contain Hubble volumes, realizing all initial conditions. Realizing all initial conditions? I might have to see level 2 and level 3 and 4 for me to understand, oh, that's what you were saying by comparison of the others.
Level 2 are universes with different physical constants. In the internal inflation theory, the multiverse or space as a whole is stretching and will continue doing so forever. But some regions of space stop stretching and form distinct bubbles that are embryonic level 1 multiverses.
Okay, small part. The bubbles are embryonic level 1 multiverses. That part I'm kind of lost on. I don't think that I fully understand, so I'm not going to pretend to. But I have heard of the idea that the Big Bang, maybe some regions of the universe kind of stopped, maybe slowed down from its expanding, but other parts, because it's not a full circle or a sphere, other parts are expanding even faster or in different shapes. Like this small region is still stretching out at a much faster rate than this side, which maybe is where we are. So we're on the side that's still expanding its universe or space, but there could be other parts that are expanding very different, which causes it, that's what causes it to be different. They're moving at a faster rate. Maybe those bubbles or pockets that are being formed are, to our understanding, level 1s, but level 2 is the surrounding theory of just parts expanding faster? No, I lost it. Sorry.
That are embryonic level 1 multiverses.
Embryonic level 1 multiverses.
Level 3 is the many worlds interpretation of quantum mechanics. One aspect of quantum mechanics is that certain observations cannot be predicted absolutely. Instead, there is a range of possible observations, each with a different probability. According to the many worlds interpretation, each of these possible observations corresponds to a different universe.
There's certain parts that sound familiar in there as well, like the many worlds interpretation. One aspect of quantum mechanics is that certain observations cannot be predicted absolutely. That is the thing that acts differently when you observe it. And I guess that's the reason why. I think it's also been said, just as maybe a fun thinking theory, maybe not a real theory, just a brain teaser or something. The particles that are behaving in a certain line, I don't remember how it moved. It either moved in a straight line or in waves, is acting that way, but it becomes a parallel world or multiverse, different reality, when you do observe it. So when you observe it and it acts a different way, that's that's it breaking and it's now acting different?
The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. They put a measuring device by one slit to see which one it went through and let it fly. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many.
So I think that that might be the reference to quantum mechanics, and this theory can't be predicted absolutely because it could just randomly behave in a way that we still don't understand. One small aspect is even simply looking at it, it can make it stop or go a different direction. You just can't predict it. So it almost just sounds like, yeah, well, anything can happen. So at that point, I don't really understand what we're talking about because anything, like, wait, what are we even saying?
Level 4 is an ultimate ensemble. The ultimate mathematical universe hypothesis is Tegmark's own hypothesis. This level considers all universes to be equally real, which can be described by different mathematical structures. Tegmark remarks that abstract mathematics is so general that any theory of everything which is definable in purely formal terms, independent of vague human terminology, is also a mathematical structure. He argues this implies that any conceivable parallel universe theory can be described at level 4 and subsumes all other ensembles. Therefore, this level brings closure to the hierarchy of multiverses, and there cannot be a level 5.
Yeah, okay. So if I understand, which I'm pretty sure I don't, I'm like 70% sure that I don't understand, but I'm gonna reiterate it anyways. It's gonna be a fun video. 4 kind of covers anything else that it could be, so there wouldn't be another theory because 4 encapsulates anything else. It's anything that you can think or grasp, and even things that you can't grasp is actually an existing reality already. It's an alternate dimension or a different universe. It's the multiverse. That does exist somewhere because it's infinite. So there can't be a level 5 because we just covered everything that could possibly exist with all of its different behaviors. Yeah, you're right. That universe does behave like level 1. That one behaves like level 2. All of them exist. Everything does, even the ones that you haven't mentioned. I've covered everything. Absolutely now there can't be another theory. Or another level, because 4 is everything.
The American theoretical physicist Brian Greene discussed 9 types of multiverses, but we will discuss them in another video. Enough head scratching for today. Thanks for watching. Did you like this video? Then show your support by liking, subscribing, and ringing the bell to never miss videos like this.
I don't know, this might be from media, but I appreciate visual learnings. It was explained, it's probably in media, but something like, I remember seeing someone say, maybe it's not the same thing, but you can go left or right on this rope. You can even go under it. But then I think how they explained it is the thing that we can't understand, that's in theory that exists, is this. So all of a sudden you can go left, right, and under it, but going under it in a certain direction means that you're either on top of this one or you're underneath this one now. And you can also go left and right on the bottom one too. Wouldn't that also mean that you could do this and then it's endless? I don't know how it was explained. Thank you so much for watching. Make sure you check out my live streams. I would love for you to chat. Come check it out. Yep. And see what video made you check it out, so I know which one wasn't skipped. Which one you're like, yeah, I'll go. It was from the science multiverse one. Do something like, yeah, go do that. Yeah, I'll see you all next time. Sorry it was a long video. Bye. Thank you for watching.